Okay, we're going to start our new unit. It's fairly short. It's on permutations and combinations. And today we're going to start with permutations, but before we get to that, we're going to look at different methods to solve some arrangement type questions. So first we're going to look at what the fundamental counting principle is. And that's basically just multiplying all of your different combinations. So this 10 times 10 times 10 times 10, that would be an example of picking a 4-digit PIN number. So for your bank, you could pick any digit from 0 to 9, so that's 10 different digits, and you can repeat them, so it'd be 10 times 10 times 10 times 10. And we could write that as 10 to the 4, or 10,000, whichever. Factorial notation is just a shortcut where if we're multiplying something and it decreases down to 1. So 6 factorial is, we use the exclamation mark to indicate factorial, and that would be 6 times 5 times 4 times 3. Oops, I forgot the 5 in there. So 6 times 5 times 4 times 3 times 2 times 1 and so on, which I think works out to 720. So let's go through each of these and look at the types of questions that come up where you'd use these types of methods. So the first with fundamental counting is the idea is we want to multiply each number of possibilities. So lots of questions that you'll get in fundamental counting will work, and you just basically multiply each choice you have for each step. So for this one, we're going to look at a PIN number. So we got a 4-digit PIN number, and we want no restrictions. So in this case, we've got 4 digits. We can put any digit in. So that'd be 10 times 10 times 10 times 10, which would be 10 to the 4, 10,000 like we had on the previous page. Okay, so now we start getting a few restrictions involved. So what happens if our last digit is even? So for even PIN number, we're going to count 0, 2, 4, 6, and 8. So that gives us 5 digits. And then we'll assume everything else can be any other digit. So in this case, we'd have 5,000. And our last example here, we don't repeat the digits. So we have 10 choices for the first one, but whatever digit we pick, we can't use it again, so then we're only going to have 9 left. Once we pick that one, we're only going to have 8 left, and then 7, and so on. So we'd have 10, 9, 8, 7, and whatever that answer would work out to. So when we multiply things downwards like that, quite often factorial will make things a little bit easier. So if you have, question was how many ways can you line up 5 people? So we'd have 5 spots for the first person, and then 4, 3, 2, 1. So instead of writing all those out, a lot of times it's easier just to write 5 factorial. Or especially if we had a really big number like 10 factorial, it'd take you forever to write it out and to multiply it all out. So it's a lot faster to use that factorial button. On your calculator, you have to hit math, and then scroll over to probability, and then I think it's number 4 on the list that has factorial. So the definition for factorial, if we just say n factorial, that is n, and then we go 1 less than n, and then another 1 less, that'd be n minus 2, another 1 less, it'd be n minus 3. We just keep on going down to 1. So if I gave you something like 10 factorial, we'd start with 10, we'd go down by 1, would be 9, go down by 2 would be 8, down by 3 is 7, and we multiply all the way down to 1. And one other definition we got to be aware of is 0 factorial. So 0 factorial is actually equal to 1, not 0. Because if we're talking about lining people up, if I said how many ways can you line 5 people up, it's 5 factorial ways. How many ways could you line up 2 people out of 2? It would be 2 factorial, or 2. And how many ways could you line 1 person up out of 1 is 1 way. How many ways can you line up 0 people out of a group? 1 way, right? And not having a lineup or not choosing anybody is also an option. So that's just a sort of a special case that sometimes tricks a few people. Okay, so let's go through some examples. So the first one is how many ways can 8 people finish in a race? So we're assuming all 8 people can finish, and we'd have 8 factorial. And that's it. How many ways could the letters in Leduc be arranged? So think of this as like being Scrabble. We've got 5 letters in Leduc. We could rearrange those in 5 factorial ways. Okay, so arranging things in order is basically our definition for the word permutation. So you'll see that word come up as well. So how many permutations of the letters in Edmonton? So it's like Leduc. We got 1, 2, 3, 4, 5, 6, 7, 8. We got 8 different letters, except the trick with this one is we got 2 O's. So So we actually have to divide by 2 factorial, and then we also got 2 n's. That means we also got to divide by those 2. And the reason for that is if we have a 3-letter word like something like Bob, if I flip-flop the B and the B around, that's still the same word. So that's why we have to divide it by 2, because we're going to get double the repetitions with the letters flipped around, but it's still going to give you the same word. So the trick is with repetitions, you want to make sure you divide by those repetitions. And here's a little note on repetitions. So if you have repetitions, basically do your total number on top. So n factorial is the total, and then on the bottom just divide by all of the repetitions. So for Mississippi, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So we'd have 11 factorial. And then on the bottom we got 1, 2, 3, 4 I's. We got 4 S's. And we also have 2 P's. Okay, so we'd have to divide by 4, 4, and 2. If you're going to do these on your calculator, make sure you put those in brackets, otherwise it won't do the division properly when you type it in. Another one here, we got how many ways could 4 boys and 5 girls be lined up? So if we put all 4 boys in a row, so we don't care what order they go in, we just want to make sure that there's the boys first. So we got 4 different boys, you'd have 4, 3, 2, 1 for the boys. And then we got 5 girls, so 5, 4, 3, 2, 1 for the girls. So that gives us 4 factorial times 5 factorial. And the next one, we got girl, boy, in alternating orders. But you can see, if we just worry about the girls first, we got 5, 4, 3, 2, 1 for the girls. Then we got 4, 3, 2, 1 for the boys. So we still get the same answer. So it doesn't really matter what order they go in. We're still doing the 5 girls and the 4 boys separately. When you get questions that have restrictions, what you want to do is basically deal with those restrictions first. And typically using the fundamental counting is usually the best choice. So when you do these repetition type questions, factorial works good. And after that, make sure you kind of deal with it as fundamental. So this first one is, how many pin numbers don't start with a 0, have no repetitions, and end in an odd number? So we got a 4-digit pin number again. So we want ending in an odd number. Let's kind of work with that one first. So that means we got 5 different digits. It could be an odd number. Okay. We don't start with 0. So that means we'd only have 9 digits for the front one, but we also can't repeat that last odd number. So we actually only have 8 for the front one, because we can't have the 0 and we can't have whatever the last number was. Now we can fill in the middle ones. So the middle ones would be, we can't have a 0 and the last one, so that means there's 8 left over, and then 7 after that. Okay. Last example that causes a little bit of troubles is kind of like the last one, the boys and girls one. So if it just says we want all the girls to be next to each other, so we want those 5 girls to be standing in a row. So we got 5 factorial for them, but now the trick is they can be anywhere in the lineup. So it can be them and then the 4 boys, and the boys can be rearranged, or it could be, say, 2 boys out front, and then 2 boys at the end after the girls, or it could be 3 and 1 either way, and so on. The key thing is you want to remember that those girls basically take up a spot. They can go in any of the spots around the boys. So we actually have 5 spots that they could go in. So we treat the groups as one large group that takes up 1 spot. So we have 5 spots, and then the 5 girls also get rearranged amongst themselves. So that's it. One other type that tends to show up sometimes is our pathway type questions. Let's just look at one of those quick. So if I said we were going to go from corner to corner, so you're going to start up in this corner, you go down to this corner, and the question is how many different pathways could you take? So there are going to be quite a few. What we have to be careful of is the repetitions. So it works out to be a lot like a repetition question, because if I was to go down 1, over, down, over, and so on, so I got 1, 2, 3, 4, 5 blocks so far, 6, 7, 8, 9, 10. We're not going to backtrack. So in this case, we're going 10 blocks no matter which way we go. So if I take a different path, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So we're going 6 over and 4 down. It's always going to be 10. We're always going 6 over. We're always going 4 down no matter which path you take. So if you kind of count out any of these paths, 6 over, 4 down. So that means we have 10 different blocks we're going to walk, but we have a repetition of 6 overs and 4 downs. We have to divide by those repetitions. And that's all for today.